What's up, guys? Dylan here, and welcome to day 18 of Advent of Code 2020 in Python. If you like this video, find it helpful, please drop a like and subscribe for the rest of Advent of Code. If you have any questions, leave them in the comments below. And just a reminder, my code will be available on GitHub, link in the description. And let's get into day 18. Man, almost only 1 week till Christmas. That's crazy already, huh? All right, so operation order. We're gonna help a child with their math homework. Unfortunately, it seems like this math follows different rules. This homework, okay, consists of expressions that consist of addition, multiplication, and parentheses. Just like normal math, parentheses indicate that the expression inside must be evaluated before it can be used by the surrounding expression. Addition still finds the sum. Okay, so the operators do the same thing, but the operator precedence has changed. So addition and multiplication have the same precedence. So I guess we just evaluate right to left, but we do parentheses first. Okay, we're going to be using stacks today. That is how I deal with expression evaluation, is stacks. But more on that in just a moment. So let's go ahead and start with open input 17.txt 17 18 1 week till Christmas as a file. Data is going to equal to file.read lines, and data is going to equal to line.strip for line in data. And just like yesterday, I'm going to solve the main problem here out, not in a function. I just decided to do it in a loop today, and you know what? That's okay, because whatever gets the job done, right? So let's go ahead and say for line in data, print line. So let's just see what we have to begin with here. So for line in data, print line. Okay, so right now we have a whole string. The numbers and operators are split up by spaces, but we can see that the open and closing parentheses are like right next to the for, and we don't really want that. So we're gonna say, let's just say line is equal to line.replace, and we're going to replace the parenthesis with a parenthesis space. And this way we'll be able to call line.split, and that'll help us out. So, and then line is equal to line replace close parenthesis and space close parenthesis, and we'll just say expression is equal to line.split. And now if we print expression, then perfect. So now you can see that each character in the expression is in its own index of the list. And so now we are going to loop through this expression, evaluating, adding stuff to a stack. And so I'm going to use a stack in this. So the way this works is kind of hard to explain. I like to normally draw it on paper, but there's no paper on a computer screen. That's easy to use, so oh well. But so take for example this last row. We are going to append everything to the stack until we hit a closed parenthesis. And then once we hit a closed parenthesis, we evaluate everything until the next open parenthesis, and then put that back into the stack. And then eventually the stack will be of length 1, or there'll be no more open parentheses or closed parentheses, and then we evaluate what is left. So I hope that makes sense. And we are just going to go ahead and start moving into the code. And like always, I will explain as we go. But just so you know, a stack is what's known as a last in, first out structure. So the first item that we add to the stack will be the last item out of it. And on the other hand, the most recently added item into the stack will be the first item out of it. So for example, if we were to just add all of these to the stack and then remove everything from the stack, 2 would be the last item or the first item removed, and this parenthesis would be the last item removed. So we're going to use that fact to our advantage. Now I'm not going to use an official stack data structure. I'm just going to use a list and kind of treat it as a stack. So let's get into it here. All right, so we'll say for char in, actually I'm just going to say ch, for ch in expr, if so if is digit, what am I doing? If ch dot is digit, or ch in, so if it's a number, or it's a multiplication, or an addition, or an open parenthesis, then we are going to say stack. What the heck did I just type? Why is that like that? Oh wait, no, that's correct. Okay, stack dot append ch. So we're gonna add everything to the stack. Else if stack, or else if char, this is where it gets fun. So if it's equal to a closed parenthesis, then we are going to say well, we want to pop stuff off the stack. So right now things are in the stack in reverse order. So we're gonna pop them off into kind of a reverse order and then evaluate them. So let's just go ahead and say, so basically our goal here is with this ordered list. So this ordered is also going to be a stack, and we are going to add stuff into it until we find an open parenthesis, and then we'll simplify the expression represented by the stack, and we'll simplify it basically an expression without parentheses in it. So we're breaking this into expressions without parentheses. So then we're going to say while expression, just kidding, while stack length stack -1. So basically while we are not on an open parenthesis, so while that's not equal to an open parenthesis, ordered dot append stack dot pop. And pop is a function available to lists, and what it does is it removes the last item in the list and returns it. So so basically, if our list was 3, 2, 1, and we call stack.pop, then list just becomes 3, 2, and it returns the value 1. So we're going to use that to our advantage. So we'll add the last value to the stack to the end of ordered. So this kind of flip flops the order on it. And then if we do, and then if the final item in stack is now this open parenthesis, then we don't want to append it to ordered, but we do want to remove it from the stack. So then we'll just call stack.pop once. Okay, and then we need to write a function to simplify an expression that has no parentheses. So we're going to say def simplify, and it could be the case, and we'll give that an expression, and it could be the case that the expression that we give it only has one character, and we're also going to be kind of simplifying it down until it only has one character. So we'll say while length of expression is greater to 1. So basically, while there's stuff to be simplified, num1 is equal to expression dot expr dot pop. And the reason why this is going to work is because expression is going to be alternating number operator, number operator, number operator. So for example, expression could be equal to 3 plus 2 plus 1. And so expression.pop would be equal to 1. And so then if we call expression.pop, then now expression is equal to 3 plus 2 plus. And then operator is equal to expression.pop. So now operator is equal to plus, and expression is equal to 3 plus 2. And then num2 is equal to int expression.pop. So now num2 is equal to 2, and expression is equal to 3 plus. And now what we are going to do is say result is equal to evaluate num1, num2, and operator. And let's go ahead and write evaluate. So def, oh, why did it import order dict? I guess that happened a moment ago. Okay, so def eval num1, num2, and operator. And if up is equal to plus, this is pretty easy, return num1 plus num2. Oops. Else if op is equal to multiply. Man, keep messing up here. What do you guys think? Num1 times num2. Okay, and then so we'll return that int, and then so result is going to be equal to that number, and then we will append it back as a string. So then expression dot append string results, and you can see here. Yes, you can see here. So now we append this result. So we added 3 and 2. So now expression is now equal to this. And the length is still greater than 1. So run through it again. Num1 is 3 and pop it. Oh. So num1 is 3 and pop 3. Operator is plus, pop plus. And then pop the last item. And expression is empty. So the length of expression is empty. And then evaluate 3 plus 3. So we get result is 3 plus 3 is 6. And then expression.append 6. And now the length is not greater than 1. So we can return a simplified expression, which is just expression 0. So return 6. Okay. So we've evaluated that. So now result is going to be equal to simplify ordered. And result is going to give us a string number, and we'll say stack dot pop or stack dot append result. So say for example, our expression was 3 plus 2, let's say 2 times 1. So what this does is then stack is going to say, okay, append 3, or append 3, and so pop 3 and append it to stack, and then pop plus and append it to stack, and then pop close parenthesis, append it to stack, pop 2, append it to stack, pop multiplication, append it to stack, pop 1, and append it to stack. And at this point, we find a closed parenthesis. So this gets popped, and then we have ordered, which is now, so now we're going to, now remember expression is a list. And expression, I guess I'll write it over here, list. So it's not special, but stack is a stack. So when we can't remove this 3, the only item we can remove is the 1 because it's a stack. So because the last item added is going to be the first one removed. So now stack.pop, which removes 1 from here and adds 1 to ordered, and then stack.pop, append it to ordered, stack.pop, append it to ordered, and then the next character is a closed parenthesis. We're going to pop it, but we're not going to append it. So now simplify will return this, and so now results is now equal to 2. Just put it in ordered, but that's not really where it goes. And then so now result is equal to 2, and append 2, add stack, push 2 to the stack. So there you have it. And so now at this point, it starts all over again. Well, actually, we reached the end of the string. So now what we need to do, now that we're at the end of the string, and this is what's left in stack. And that's all well and good, but say for example, our original expression was 3 plus 1 times 2, or something like that, right? But say, for example, our original expression was 3 plus 4 plus 1 plus 2. Then that would leave us with 3 plus 4 plus 2. Well, it doesn't matter. So let's say, for example, this was our original expression. So then now stack is left like this. And if we evaluate stack in this order, in reverse order, we get 8 plus 3 is 11. But we want to evaluate it right to left. But we can't do that with the stack because we can only remove this item first. Because we want it to be 3 plus 4 is 7, then times 2, since multiplication and addition are just evaluated right to left. So we are going to call stack.reverse. And at this point, stack now becomes 2 times 4 plus 3. So now that we have no parentheses, and it's in the correct order that we want to evaluate it because we want to evaluate 3 plus 4 times 2. Remember, so now we can say result is once again equal to simplify. And this time we are going to simplify stack because it's in the correct order. And this is just, result is going to be equal to some number. And what are we trying to even solve for in this problem? Evaluate the expression on each line, and what is the sum of the resulting values? Okay, so let's have total is equal to 0. And then total plus equals int of result. And, well, for one, we didn't get any errors, which is a great sign. So print total, and let's not print expression. And that is a big number. There must have been a lot of problems to do. That's a terrible homework if there's that many problems. All right, and there you have part 1. So I'm guessing we're going to add precedence in for part 2. Okay, so now advanced math. Now addition and multiplication have different precedence levels, but not the ones you're familiar with. Instead, addition is evaluated before multiplication. Okay. So this is going to be similar. This is going to be real similar, okay, but slightly different. And similar but different, you know? Big brain. So I think what we can do here is say for part 2, we will reuse the simplify and evaluate functions, I think. But for now, let's just go ahead and copy our code from before. And let us see what we need to change. So this is all the same, blah, blah, blah. Okay, I'm going to get rid of this because I already explained it. Okay, so now so everything is the same up until this point. But at this point, we have an expression, and although it doesn't have parentheses, we have to account for precedence. So we're going to say def simplify with precedence. And let's see if we can figure this out. So we're going to give it an expression. And same as before, while length of expression is greater than 1. And this time we're going to have an ordered list and a list of numbers on hold. And hang with me here. So now what we need to do is so we're given the expression and we need to pop numbers off into hold, and because remember, expression here is a stack, and we need to put numbers on hold until we find a plus, and then we can evaluate the plus. So we're essentially going to get rid of all the plus operations because in this case 3 plus 4 times 2. Well, normally this would evaluate to 8 plus 3 is 11, but in our case, this needs to be 7 times 2 is 14. So, and then we're going to say done is equal to false. So done will become true when we find a plus. So while not done, hold dot append expression, or we're going to say char is equal to hold dot or expression dot pop. If char is equal to plus done is equal to true. And no matter what, char or hold dot append char. So now once we're done, so once we find a plus, then we are going to say ordered dot append expression dot pop. So basically what this does here is if we have this expression 2 star 4 and plus go into hold, and then we put the next one into ordered, and then we're going to pop off these two. We're going to pop off plus and 4 from hold. So now we'll say we're just going to do 2 pops from hold for blank in range 2 ordered dot append hold dot pop. And so now to hold, we are going to, well, we can say result is equal to simplify ordered, because now this expression ordered is only going to have pluses, so we don't need to worry about precedence in it, and we can use our previous simplify function. And then hold dot append hold.append result. And then for, well, while length of hold is greater than 0, so then while hold is non-empty, expression, add everything back to expression, hold.pop. So what this does then is it adds, so it's going to simplify, so everything in hold is going to be added back to expression, and we start again until eventually expression has been simplified down to one number. Now, I believe there's an issue here, because what if this expression doesn't have any plus signs? It'll loop forever because, or it'll hit 0. So while not done, and length of expression is greater than 0. So say we pop everything off without finding any pluses. We'll say if length of expression is equal to 0 and not done. So we've popped everything into expression and we did not find any pluses. Then we'll just say result is going to be equal to simplify expression. And again, this expression has no pluses, so again, we don't need to worry about precedence. And then we'll say else. So else is going to be everything here. Hold.append results. And then while hold is length of hold is greater than 0, expression.append hold.pop. And I think we're going to change this. We're going to bring this under here. And then because expression is empty at this point, we're just going to say expression.append. And then return expression 0. So hopefully this works. Fingers crossed. So at this point now, we've simplified it according to precedence. And we've simplified at least everything down to no parentheses. And then we've reached the end of the string. So then we'll say, once again, stack.reverse. Okay, let's just see if this works. There's probably an error in there somewhere. Oh, goodness gracious. Gave us the exact same answer. That can't be right. That is because we did not change this to simplify with precedence. Okay, line 21, index out of range. Okay, guys, and I think I found the answer after some debugging. So the issue was that in this, calling this statement while evaluating expressions, we said result is equal to simplify expression. Well, in this case, expression is of length 0. So we need to instead simplify hold, because at this point, all the characters are in hold. So just simplify that. And if we go ahead and run now, hopefully no more index errors. Okay, so we got a bigger number this time, Control C. And let's go ahead and try that out, Control V. That's not good. All right, and it told us that is not the right answer because the answer is too low. If we're stuck, make sure we're using the full input data. Okay, so let me go ahead and take another look. Alrighty guys, so for some reason at the bottom of my loop here, while counting up the total, I don't know what this if statement is all about here, but we're going to get rid of that and just do what we did up above. So we're going to say stack.reverse. Total is equal to simplify with precedence, stack, and not total. This should be, we'll just call this result. And okay, total plus equals int result. Yeah, I don't know what that was going on, but I don't think we were counting enough of the expressions into our total. So now, okay, our number is quite a bit larger. So now let's go ahead and try that. Oops, yeah, you can see I was testing values. Why did that not copy? Okay, and there's the answer. So we got to work with some stacks today. Hopefully that all made sense. If you enjoyed the video, found it helpful, please drop a like down below, subscribe for more, and I'll see you tomorrow for day 19.